Hello, welcome to another video of Python scripts for Abaqus. Today we will be discussing on explicit analysis of a loaded truss. This is the truss we are dealing for the analysis. As you have already seen, these are the three import tools that are very much important in order to make the Abaqus get ready for the Python script to run. This is the name, a given name by the Abaqus. We need to change it to our required name. So I took the name as truss. You can change it to whatever you like it. It is the truss model. Basically we are doing it like x equals to y, so that we can change, we can name it anytime x in place of mdb.merge. As this is very big, we need to type every time we need to write this script, so that for our convenience we will be taking some variable or the string, so that we will reduce the time and monotonous work to type the script. So these are the points for the line. I took the line to make this step. This is the first line, 0 to 2 and 0 to 1.5. This is the second line. This is the third line, fourth, fifth, sixth and seventh. We need to give the part name, and as you might have seen this before, if you are experienced, you need to take the name for the part model, set the dimensionality, that is 3D or 2D planar, and type the deformation or non-deformation point. This is the material used for the material definition. I took this field. This is the section that is to be done for the truss. Sections are basically the midpoints or midpoints of the truss elements. It is dividing the parts into number of nodes and elements. That is what this section does. We are making an instance by taking the assembly, and at 2, 1.5, 0, that is here, we will be applying force, and we also will be checking how the end vertex of the truss is going to react. We will be doing it in explicit dynamic steps. So the time step is 0.01 seconds. At this point step, there is no much difference in the load applied. So the force we need to be taking more than 3 kN downwards. This is the history output request. And here comes the load application, which is a concentrated force. I took the name as force pulse. Create step is loading step, and the region it takes is the force vertex. The force vertex is given in the while giving the assembly step. Here we have assigned force vertex to the instance. So we will be taking it in order not to get an error. You need to maintain it. You need to keep it in mind that we have given the instance as force vertex. So after application of the load, see here I have taken 10,000 Newton downwards. The point at E is completely encasted, that is degrees of freedom is 0, and at point 8 is rolling condition. That means U2 is really movable. In Abaqus, U1, U2, U3, U4, U5, U6. U5, U6 stands for U4 to U6 stands for rotation in XYZ plane. U1 to U3 stands for the translation in XYZ axis. Here, the U2 is set. That means it is movable in the Y direction. And this is the import mesh. Adjuster meshing we have given over here. That is in this section part. And now this is the element code C2D2, and the final job name is given as first Explicit Dynamic Analysis job. We need to give the model as a truss, as we have mentioned in the while changing the name mdb.models to truss. So we need to be keeping it in mind throughout the script while we run it wherever necessary. This is the general syntax, and these are the optional values. You can change it whenever or as required by this script. Most of the things here is just the basic default procedure. You need to keep it in mind where we need to change the syntax. That is it. This is the easy procedure to change whenever we want to make a changes. If at all we need to do it in graphic user interface, you need to delete it again and start from the ground, start right from 0. So Python script enables us to change the script whenever we require and easily run it in the Abaqus software. So now let us run the script in the Abaqus. So for this, go to File menu and then run the script. Go to tutorial. I have done it in the Python script, so I'll run this. So the running of the script depends on the processor you have and the RAM even. It takes a while to run the script. The analysis displayed in the message area that the analysis input file processor completed successfully. So let us wait till the Python script is run completely in the Abaqus. It shows that the analysis is done. So let us now see this. Like if you can observe over 4.4, there is a deviation. This is the deviation applied for a time step of 0.01 seconds. The load applied is 10,000 Newton at 0.2. So for the time step, for a very short time period, this is the deviation. If at all, as I have shown you, this is 3 kilonewton downward. If at all I have used it, the deviation or the deformation from the original one will not be the same as you have as we are seeing over here. So that is for what I changed the load application to -10,000. So this is the Python script for the explicit dynamic analysis of a loaded truss.